Okay, so in the last video, we ended with a picture that looks something like this, right? Where we graphed our optimal choice of leisure as a function of our wage, and we argued that it should be decreasing, right? Our optimal choice of leisure should decrease as our wage increases from low levels of wage, but then it's going to increase as wage increases at high levels of wage. And the reason behind this, right, is that when our wages are very low, we're using our leisure time on things that we can get with money, right, that we can buy with money. When our wages are very high, our remaining leisure time is precious, so the income effect is going to dominate the substitution effect, right? As our wages go up, we're going to react by saying, now that I'm really rich, right, now that I can afford to have more consumption working less, I want to spend more time doing the things that I enjoy. So let's think about how to take this and translate this into a labor supply curve, right, to find out how many hours people are going to spend working at different wages. The way we're going to do this is actually very straightforward. All we need to do is remember that our time working is just the time that we're not spending in leisure, right? So if we're spending 24 hours in leisure, we're spending 0 hours working, right? So at a wage of 0, we spend 0 hours working. If we spend, let's say at a wage of $10 an hour, we would spend 20 hours in leisure. That means that we would spend 24 minus 20, or 4 hours working, right? If we spent, right, 14 hours in leisure at a wage of 20, that would mean that we would spend 10 hours a day working. Right, and so on and so forth, right? If we spent $50 an hour, if we spent, let's say, 22 hours a day in leisure, right, then we would spend 2 hours a day working. And so our labor supply curve is just going to look like effectively the mirror image of our leisure demand curve. Cool. Okay, so there's not too much to this, right? All we're saying with this is that our supply of labor is just the time we don't spend in leisure. So why don't we take a minute before I end today going over how to solve a problem, how to find labor supply given somebody's preferences and constraints. So let's say that you've got preferences over leisure and consumption that are Cobb-Douglas. Let's say, say 2 log L plus log C. And let's say that in addition to the money you get from working, your grandma also is very, very generous, sends you $6 a day. So first of all, let's think about what our budget constraint is going to look like. And we can do this by thinking, for any given amount of leisure time, right, how much consumption can you afford? So we'll say, well, the consumption that you can afford is going to be your wage times the time you spend working, right, 24 minus L, plus your non-labor income, right, so $6. And I'll rearrange this to be C plus WL less than or equal to 24W plus 6. Good? If I graph this thing, right, the most leisure that I can afford, it's not actually 24 plus 6 over W, right? I only have 24 hours in a day. But if I decide that I'm not going to work at all, right, I'm going to take 24 hours of leisure, then I still have the $6 a day for my grandma, right? So I still have a consumption of 6. On the other hand, if I took leisure of 0, right, I would have 24W plus 6 as my consumption, right? So my budget constraint is going to look like this. We can make that line solid if we want, because I could always not cash my grandma's check. And I'll have a slope equal to W. Cool. Okay. So what we want to do, right, is we want to solve this problem for any given W. So why don't we start by finding our marginal rate of substitution, right? That's how we start all these problems. We'll say my MRS of leisure and consumption is du dl over du dc, right? Du dl is just going to be the derivative of 2 log L, so it's going to be 2 over L. Du dc, it's going to be 1 over C. So my MRS, right, is going to be 2 over L divided by 1 over C is going to be 2C over L, right? Does this make sense? What we're saying is, right, our MRS is defined as the amount of consumption we're willing to give per unit of leisure. That's going to be higher the more consumption we have, lower the more leisure we have, right? And if we had the same amount of consumption and leisure, it would be equal to 2 because we weight leisure more than consumption in our preferences. Cool, 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 right? So here's our MRS. So now let's think about what sort of solutions we're looking for. Are we looking just for interior solutions, or is there the possibility of a corner solution? Now what you're probably thinking is, there's no chance of a corner solution, right? Because if consumption was 0, my MRS would be 0, and if leisure was 0, my MRS would be infinity. And you're right about that, right? Our MRS would be 0 if consumption was 0. But if we think about our corner here, at our corner, consumption isn't equal to 0, consumption is equal to 6, right? My corner solution is, if I have a corner solution where I take as much leisure as possible, my corner solution is that I don't work at all and I just live off of the check from my grandma. So we need to think about whether that is possibly a corner solution. How could this be a corner solution? Well, I would have to have an indifference curve that looks something like this, right? It's steeper than my budget constraint at the corner. So horizontal corner is possible if my MRS as a function of L and C is greater than or equal to my price ratio, which is W. Does this make sense? Great. Okay, so that means that 2C over L has to be greater than or equal to W when L equals 24 and C equals 6, right at the corner. So 2 times 6 over 24 greater than or equal to W. In other words, I'm not going to work at all, right? I'm going to have a horizontal corner solution if 12 over 24 is greater than W. So if W is less than or equal to 1/2, right? At a wage less than 50 cents an hour, you say, forget about working, I'm letting my grandma take care of me. How about if there was a wage greater than 1/2, right? Then we would have some sort of an interior solution, right? There's genuinely no chance of a vertical solution because of consumption. If leisure is 0, we would in fact have an MRS of infinity, right? So then the interior solution, which is going to occur if W is greater than or equal to 1/2, right? In order to have an interior solution, I need to have my MRS equal to price ratio, which is just the wage, right? So 2C over L equals W. Let's say C then is going to equal WL over 2, right? Plug this into my budget constraint. So then I would say C plus WL equals 24W plus 6, right? So WL over 2 plus WL equals 24W plus 6, right? So that means 3/2 W times L equals 24W plus 6. L is going to equal, right, 2 over 3W times 24W plus 6, which is, right, 2/3 of 24 is going to be 16. 16 plus, right, 2/3 times 6 is 4. So plus 4 over W. Right, so all told, my choice of leisure as a function of W is going to be 0 if W less than 1/2, less than or equal to 1/2, and 16 plus 4 over W, right, if W is greater than 1/2. Cool, cool, cool. So now I know how much leisure I'm going to consume, right, at any given W. If I graph this thing, right, we're going to have leisure equal to 0 up until the wage is 1/2. And then from there, it's going to be 16 plus, it's going to be 24. What am I doing? It's going to be 24 if W is less than or equal to 1/2. Right, and then it's going to be 16 plus 4 over W if W is greater than 1/2. Right, so that's going to be at a wage of 1/2, right, that's going to be 16 plus 8 is 24. At a wage of, let's say, 1, that's going to be 16 plus 4 is 20, right? And if I let the wage get as big as it possibly could, right, if I had a wage of infinity, the lowest my leisure would ever get is 16 hours, right? So I'm going to end up with a picture that looks something like this, where as my wage gets higher and higher and higher, I'm going to take less and less and less leisure, but I'm never going to get less than 16 hours of leisure. The last step here is how do I turn this into a labor supply curve? All I do, right, is I say 24 minus leisure is going to be labor supply. So my labor supply as a function of W is just going to be 24 minus my leisure. By the way, the fact that labor and leisure both start with L is one of the biggest problems in labor economics. There's really no solution. So this means that my labor supply as a function of wage is going to be 0 for wages less than or equal to 1/2. And it's going to be 24 minus 16 plus 4W, which is going to be 8 minus 4 over W if wage is greater than 1/2. Right? If I graph this thing out, right, at a wage of 1/2, I don't work at all. As my wage increases, I work more and more and more, but I never work more than 8 hours, right? So it's just the mirror image of my leisure picture. Okay, so that's all I've got for today. Thank you so much for sticking with me. I look forward to talking to you about this soon, and congratulations on making it through Unit 1.